What I'll talk about, the main theme is open science. So this is not a technical talk, but it is affecting all of us when we do our technical work. Before that, I want to say a couple of things about ACM that leads into where we are. And for those of you who were at the opening ceremony of the conference, I want to repeat this slide that talks about the ACM mission, and I'll go over it very quickly. ACM is a global scientific and educational organization dedicated to advancing the art, science, engineering, and application of computing, serving both professional and public interest by fostering the open exchange of information and by promoting the highest professional and ethical standards. This is a mission. ACM is 77.5 years old. This mission was written from the original one about 30 years ago. And I want to emphasize the word open. This was way before anyone conceived open science, conceived open access, anything about openness in a way that is being discussed now. Well, the ACM people 25, 30 years ago, they said, we have to be open. And this is the key word from the mission that I'll talk about today. I want to also to say that ACM operates with certain values like any other organization: excellence, advancement, positive, ethics, and of course, diversity, equity, and inclusion, that I think we should keep repeating ourselves, that this is a principle that is foundational and not something that you can scrap with an executive order. The ACM Digital Library is at the forefront of open science, and a particular element of open access that I mentioned also in the opening. If I ask you, can you raise your hand, how many of you have used the ACM Digital Library? Okay, good, about half. Well, for the rest of you, you just don't know that you have used it, but you have used it already, because you search for something through Google or other search engine, and then a paper pops up. It has gone to the digital library to bring it. So this is a crown jewel, a product or service of ACM that we're all really proud of and helps our lives. So let me go into open science now. What is open science? Most of my talk does not have text. It is artistic renditions, and it's artistic by a computer scientist. So I hope you're lenient on your criticism on how things are. So here is the research life cycle that roughly we all go through. Some corners have been left out, but this is the essence. There's a researcher, has a hypothesis, has an idea, then decides on the method to follow to prove or disprove the hypothesis, decides on data, possibly human subjects, software, hardware that they will use in this process, and eventually gets some results, verifies the results, stores the results. When everything is done, archives the results somewhere, then writes a paper about it, publishes, disseminates it through means like ACM, through publisher, and so on. And then people read this. And this is the research life cycle, more or less as we know it. I started from a researcher having a hypothesis, but some research starts at a different point. May start, well, generate tons of data and let's see what works, or let's read for 3 years and then we'll decide what hypothesis we want to go after. Roughly, this is the research life cycle. And that's the way we know it. And the way we know it, after we publish, everything below the line is forgotten or destroyed or very quickly becomes inaccessible. We lose it. And in addition, in the current non-open access world, why is this not working well? Okay. You subscribe to a digital library, you subscribe to other corpora in order to read. You read, you pay to read. This is the current world where we live in. Let's go now to an open science research life cycle. What is the difference? The biggest thing is that this line doesn't exist. You keep everything that you have generated or hypothesized or used in your research. in order to achieve many of the things that I'll mention later. And also, you don't pay to read, but you pay to publish. Because publication, that process has some cost. Someone has to pay it. These are the two main differences, but they're very fundamental. They're just two phrases, but they're very, very fundamental. And now, I said everything is open, but we have to tone it down a little bit. It's as open as possible, as closed as necessary. For example, if you're dealing with medical data, there are privacy issues that cannot be completely open. You have to do something about it. And in some other cases, on things that you keep. So closed as needed. But openness is the key thing. And of course, every single step in this life cycle changes when we do it, how we do it. I mentioned a few things here, and as we go through the rest of the talk through these steps, I'll mention a few of the things of how every step is changing. And let me say now that for most of these, I'll present them in the extreme. So extreme openness, extreme changes from what we are used to. There are many intermediate steps in each case, but to make my point, I'll be presenting them in the extreme. And then, okay, you may say, okay, openness, that's good. I mean, it's a good principle, but there is cost. It takes time to be open. When it was closed, I mean, you wrote a code that is unreadable. You came up with some results. You don't have metadata. You have them in your head. Nobody else will look at them. You can afford to do this. But when you have to be open and the world will look at your data, then you're careful. You have to have IDs. You have to clean up. You have to have metadata, and so on and so forth. It costs. So every single step, again, comes with additional effort that the researcher or a research team has to make. And when you have and you reach the concept of an open science publication, don't just think of, as you saw in the picture, don't just think of the text, of the paper, as we call it. Rarely we have paper now, it's all electronic, but we still use this term. Yes, it's the paper publications, but also the research data, the lab books, the software specifications, the hardware specifications, education resources, everything is part of a publication because then, because you need to have to associate everything with that. And therefore, in that sense, we are moving away from the concept of having text with some pictures and some references and so on. It becomes something more complicated. The very definition of what a publication is changing. And if I want to just draw it, okay, you have this text that is written, but you go beyond. You have a digital object. You have a knowledge graph, if you want. An ontology, depending on where your background is, you may like one term or the other, and so on. So the authors as entities are part of that, not just a name in the front page. The presentation that is given and is recorded is part of that. And how the slides or how you teach about it. And of course, the hardware that was used, the software that was used, the data sets that were input to the software and then what was generated, and the relationship. And of course, it's a live publication. It's a live research object. So when things are added or corrected or more information is happening, versions of of that paper is that. So you don't have something that is linear, like a paper. You have a knowledge graph that is searchable and dynamically changing and so on. Open science. Okay, you may say, okay, fine. Why do we need open science? What do we gain? What is the motivation behind being open science? Why did people want it? Well, let me look at, I showed you the research life cycle, the way we researchers experience it. Let's see how it looks from the outside. Okay, the outside world looks at the researcher, and the researcher has a hypothesis. And the researcher typically writes a proposal about it and goes to a public funding agency. And if it's accepted, then you get some dollars. US dollars, Australian dollars, doesn't matter. It's some form of money. And then there is an opaque world that is called research, and then the world sees afterwards a publication. What I showed you before, the research life cycle that we went through, people don't know about it. They don't know what did these people do, how did they do it. They just say, okay, they got this money, and they came up with that publication. Now, the researcher belongs to an institution, also belongs to some scientific community, and the whole world is for the researcher to be glorified. Most of how we do things is so that the researcher is glorified by their institution, to be promoted, by the scientific community, to be invited to give keynotes or to be in the program committee and so on and so forth. And by doing it this way, with all this opaqueness of how we do research, there is very weak collaboration across rooms or across corridors or across institutions. There is no reproducibility, because as we said, in the usual way, all the data, everything is lost. And there are inequalities. Some people, equally smart, equally inventive people, some of them are in an environment they can do research, others they cannot. Also, if we look at industry, again, very weak collaboration between industry. And with few exceptions, technology transfer from the research that we do to something that may create wealth, may affect people's lives, is very weak. And then let's look at society. It is society that is giving the money through taxes to the public funder so that they can fund a proposal of the researcher. And there's no transparency, no accountability. Society paid us, and then suddenly we have a publication that is often possibly visible after you pay. And the key word that I mentioned in my opening, and I'll mention at the very end of this talk as well, there is no trust. And let me emphasize a few of these negative things that arise from when we follow the research life cycle the way we're used to, not in the open science way. There is no reproducibility. These are a few years old, but even the new data are very similar. Is there a pointer here? No, is there? Yes, there is a pointer. For various types of sciences, we belong to physics and engineering. You see that if you try to reproduce someone's paper, 70% we cannot reproduce in science and engineering. Some other fields are a little bit better, like in the other social sciences, and chemistry is the worst. Interesting, even if you try to reproduce your work 6 months down the road, for us, where we belong, 50% of the cases we cannot reproduce. We forgot how we did it. It was in our graduate students' head. They left. Things are not reproducible. And reproducibility is a foundation of science. If you cannot reproduce, then how can you say, oh yeah, they were right? Just because they said it and I wrote it in a nice way, it doesn't work. So we have a tremendous problem of reproducibility. The other thing about non-reproducibility is that often we do some research, we have a hypothesis, it doesn't work, but then we say, okay, but we did some work, let's see what makes sense. And then we come and say, we interpret the results the way we want, okay? It has nothing to do with hypothesis, whatever comes out. And there is this concept harking. Has anyone heard of the concept harking? Okay, one, okay, good. I'll show you a picture a little bit later, but think of it, what could it be, HARK? It's an acronym. The other thing is about inequalities. Scientific publishing is really big business. You would never think about it, but roughly, it's a $25 to $30 billion business. This includes scientific books. It's not just scientific publishing of research papers and so on. But there's a lot of money going on there, mostly from commercial publishers. Okay? And I won't say anything bad about them. You see, they were growing business around COVID. You know, things kind of fell a little bit further down. And now they're going and going and going towards 30 billion. This is commercial entities that don't do research. They take our results, the publicly funded results, and they make $30 billion out of it. Okay? Very far from what was happening at the end of the 19th century, early 20th century, where academies were the publishing units, where institutions, universities were the entities that were publishing things. And then because of scale, at the time even, forget now, they said, can some companies take care of this? But that was the printed world. Things can change now. The other thing is mistrust of science. There is truly the way we do things, and because of this opaqueness, you end up having random people not trusting science, not trusting scientists, and now, as of recent, cutting budgets, not worrying. Just a few quotes. This is from Trump 1.0, not even 2.0. What is it? I don't believe it. This is for climate crisis. Okay, climate change. The environment is very important. Someone wrote a book that I'm an environmentalist. It's freezing in New York. Where the hell is global warming? These are official, these come out of the mouth of an official person. Okay. If we were open, maybe some of these would not be there. And of course, this becomes good motivation to write amazing movies. If you haven't seen the movie Don't Look Up, it's very funny, it's very stars, lots of stars. It's a great movie, but it captures reality. That's the annoying thing, is that it captures reality. The United Nations cares about open science for quite a few years now, and for the same things, reproducibility, collaboration, trust, and so on. And there are, in addition to us thinking, well, this is our science, we have to do it right, we have to open it, we have to collaborate to get all these things, governments also come and have mandates. In the Obama administration in the US, there is a mandate from 2026 for publicly funded research. The results should be openly available. Europe was even earlier than that. Latin America, Canada, in many countries, there are either at the national level or at the institutional level. And you see a map of where there are governmental mandates. Does it work? I mean, is there an impact to be open? We talked about openness philosophically. Is there a true impact? Well, the COVID pandemic is an amazing example that we didn't try for it, it came on us, where openness helped. Immediately, very quickly after the pandemic was defined as such and so on, all publishers, including the commercial publishers, said for 3 months or for 6 months, we are opening up all publications. Go find a vaccine by having access to all the data sets that exist. Public infrastructure said the priority is openly, without any first come, first served. We are open to your experiments. And in record time, 1 year, unprecedented in the world's history, we were able to have a vaccine. Openness was not the only reason why we achieved that, but certainly it helped. And then there are many financial studies that even at the economic level, for society or even for people, openness pays. And of course, every open publication gets 3 times more citations than a closed publication, so we also have the self-centered benefits. What happened? Okay, now let's move. I explained to you the why open science, why we want to go this way. Let's see how we go open science. And that will take me in various spots around the research life cycle and how things are changing. I won't go in the order of the research life cycle. I'll go in some order anyway. Let me talk about open publications. So I'm focusing on you have the data, you have the data, you have your results, you're publishing your paper. There is a science called scholarly communication, and there are scientists that are looking into the processes of scholarly communication. It's a social science. And they say there are 4 reasons why we publish. To register and say, you know, secure, this thing, Yannis did this thing. Second, to validate, peer review, a fundamental aspect of research. 3 people, 4 people, 8 people reviewed this paper and said it's good, to validate this. Third, to distribute so that the world knows about it. And fourth, to archive it so that 100 years from now, your grandchildren, academic grandchildren or physical grandchildren, can go and back and read, yeah, this is what Yannis did. I will separate the process of registration. I'll show you why registration and archiving can be bundled together, and validation and distribution can be bundled together. So let's see what is the world of publishing in the printed version, what we had until about 10, 15 years ago. Here's an author. They write a paper. That's registering. Then they send it to reviewers through some conference, some journal, whatever it is. And then if it is validated and it's accepted, you get step number 2, validation. And then some newer version, it's sent out, it's in a proceedings or a journal and so on, and the world can read it. That's distribution, step number 3. And then at some point is placed in an archive so that for the world to have it until the end of time. So this is what is happening now. This is what we want. These are the 4 motivations for why we publish. And when it was a printed world, all these 4 things had to be done by a single organization. But if we move now to electronic publishing, in the concept that is scholarly communications, people talk about, say, it's overlay publishing. The flow changes a little bit. The author doesn't send a paper somewhere to be evaluated, but sends it directly to an archive. So step 1 and step 4, registering and archiving for eternity, happens first. And then, either in a push or a pull mode, this paper is being validated through a review process, and then the rest is the same, and the final version is archived in the world. In this electronic world that we live in, and not the printed world, you can separate these steps into 2, and you don't need a single organization to do it. You can have an archival organization, or an organization in the role of archiving that captures the first part. One example is archive itself, that's the name of it. And then validation and distribution can be done by a publishing organization, and I'm just showing my favorite publishing organization, ACM. What is the problem? There's no problem so far in this picture. The problem is that because of scale, because of arrogance of us, of the scientific community, often what we do is just exposition publishing. We forget the validation part. Oh, wait, I put it in an archive. I'm fine. Why do I care about peer review? It will be there forever. And us, scientists, are also drawn into this, and we start referencing papers in archive. Are they correct? Are they wrong? Doesn't matter. I can write down any garbage things I can do it. I can put it in archive, and then people can reference it, and people do that. And that is against the very nature of the scientific process. Exposing something. And this also leads us into what the technical term is paper diarrhea. I sneezed, here's a paper, I write about it. I sneezed again, here's another paper about it. I put it on archive. No validation. Or maybe I'm trying to do validation, and that's why we have, what was the number here, 2,000 papers, 1,500 papers here. I heard about multimedia, 8,500 submissions. And in conferences like NeurIPS, 20,000 submissions. This is not healthy. So exposition is not publishing. Let me go now to open conferences. The same way we have 4 motivations for why we publish. Why do we come to a conference? And I'll say, why do we, in the computing field, go to a conference? No other science is doing what we're doing. There are 3 motivations to come to a conference: to publish, to present, and to interact. 3 different things. Let's unbundle these 3. So here is, why do we publish? Conference. So we start from some place on Earth, we go halfway around the world, okay, to publish. Again, only computing science is doing this. Why? A paper, as a publication, doesn't have to be related to some travel or to some meeting. You can have a paper, you can have it in a journal, and the world will look at it, will see the publication, you'll see the result. Oh, I'm going to a conference to present. What does it mean to present? I'm going on a plane half the way around the world to stand as an author in front of 5 people or 50 people or 500, doesn't matter. And for 20 minutes, blah, 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 I'm talking. Click, another slide, blah, 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 I'm talking, and so on. I give a canned presentation for 15, 10, 20 minutes, whatever the conference is allowing. Why do I need to do this? Why don't I just record it in a YouTube or some other channel? I'm not advertising YouTube here. And have that canned thing. You don't need to go halfway around the world in order for people to hear you speak for 20 minutes and show 35 slides. Conferences, the 3rd motivation, interaction. Yes, you cannot do that unless you go half the way around the world. But we have Zoom. It's a different story. You cannot drink beer from the same bottle if over Zoom. Okay, you cannot stumble upon someone on the corridor. Okay, you cannot breathe the same air. So you go to a conference, you interact around your work, around your paper with many others, and then ideas come in. That's the only reason why we should have conferences. Like all the other sciences, which are much more mature than us. We have to go to conferences to confer, not to publish, not to give canned presentations. And that is part of the overlay conferences. It's part of the nature of conferences and where openness leads us to. And this solves a whole bunch of other problems as well. Inflation of conferences, inflation of papers, environmental impact. I won't go through them. But the key thing is, let's spend the 3 days that we're here if the conference had a different structure. It is a wonderful conference, by the way. I really enjoyed every moment and where I went to. But can you imagine, instead of having, I don't know, 10-way parallel sessions, technical sessions, where people were giving for 15, 20 minutes presentations, if we were, all this time was spent in a much more interactive way. There are piloting of these things across sciences, but also in computing. And I don't know where we'll end up in terms of our scholarly communication in 10 years, but I know it will not be the way we do it now. So in the open science, if you do research work, let me combine all this in one slide. the way I see a direction where our community has started going towards, partly. It happened also in this conference, partly. Not all papers accepted were given an oral presentation, and that's in the right direction. So here is the researcher with their work. They send it to something like archive, and then this is sent. And this is exposition. This is the sneezing part. And you can sneeze as much as you want. That's fine. It's like a blog post. Often what we do with a little bit of work that we want to expose it, fine, expose it. It's a blog. But that's not a publication. That's not, doesn't have the fundamental element of peer review. But then an organization like ACM or some other formal publisher comes in. You go through the publication review, and then you publish to a journal. Publications should only be to a journal. The concept of conference publication, again, doesn't exist in any other science, only us. And maybe 50 years from now, when we invented it, and we convinced our deans and funding agencies that this is the way computing works, maybe it made sense then. It doesn't make sense now. And then in the same, okay. Of course, you can do this with data sets, not just papers. You can do it with presentations. And if you want to have the canned presentations officially as part of some event or some corpus, you can even have presentation reviews. And then you can say, okay, this video is fine to have an ACM stamp, for example. And that's you achieve your presentation, canned somewhere. And then you go to a meeting which is structured differently than all our meetings are. And you go by invitation because of a paper you wrote in a journal, because of a presentation that was there, because of something that you exposed and it's really interesting, or because you are Donald Knuth or whatever, and because of who you are invited. And all the conferences are by invitation for people to come and discuss and confer in posters, in meetups, in like a technology exposition, in various corners, things are happening, in panels, in plenary presentations, and so on. And then good ideas come in. You go to a conference to interact around work, but not to publish, not to present canned presentations. This is an end. There are many intermediate steps until now, until this point. As I said, even within ACM, but also elsewhere, people are experimenting with aspects of it, with parts of it. And of course, we cannot go there until all of us decide to go there. We cannot do it as a scientific community and have the deans say, okay, where are your conference publications? You'd convinced me. Or the funding agencies. Why are you going to a conference? You don't have a paper. We have to change. We have to all agree. And ACM, together with sister societies, IEEE, CRA, AAAI, so on, are working on coming up with a manifesto, if you want, that changes some of these things. And it's related to evaluation. So open science leads us to a very different way of scholarly communication. And the benefits would be great in many ways, both fundamental motivations and also many great side effects. Let me go to another part, open reviews, okay? Reviewing, as we said, is for validation. It is fundamental peer review. And people say this has to be open as well. What does it mean? Okay, the classic evaluation. Here is the author. Here's a paper. Send it to a reviewer. The reviewer writes a review, sends back to the author. If it's positive, eventually it's sent to the world. If it's negative, it's returned to the author. So, and the review, no matter what it is, goes to the garbage can. The review is forgotten. Now, in the world that we lived in for the most part until 10, 15 years ago, and for some cases even now, this process was what is called single anonymous. The reviewer knows who the author is, what the paper is, the review that they wrote, and so on. But the author knows the review in the paper, but she does not know the reviewer. So it is not a symmetric thing. What's the problem here? Well, the reviewer may be a bad reviewer, hidden behind anonymity. And therefore, the review that they write may be bad. For whatever reason, they didn't wake up well that morning, or they don't like the area, they don't like the author, doesn't matter. And when the paper is accepted, you need to change the batteries in this. Okay. Then the world, all they see is the final version and who the author is, nothing else. In recent meaning in the last 10, 15 years, maybe 20, when this world changed and we went to double anonymous. So we made it symmetric. The author, the reviewer also does not know the author. Although many people go at length to break this, but in principle, okay, yeah, let's try, okay. The reviewer doesn't know. And this is, yeah. So the reviewer may be better, still is not, pure, because still they may have woken up, without having enough sleep that morning. But at least by not knowing the author, they cannot have a grudge against them or be in favor. Still, the world only sees is the final version and the author. Nothing else is seen. But in the open evaluation, from single anonymous, we went to double anonymous. No open reviewing says go in the other direction. Zero anonymous. All of this is in the open. The world knows the author, the paper, who the reviewer was, what the review was about, what was the review written. And not only the final version, but also the original version as well. Nothing, the garbage can is not in it anymore. We're reviewing openly. Now the reviewer, just because of the danger of being ridiculed if they write a good review, okay? The review is good. Otherwise, they're exposed. Of course, now we have the opposite, that the author may see, this graduate student wrote a bad review about my paper. They will see when the time comes for me to write a recommendation letter for them. Or promotion, or I'll read their paper some other time and so on. So we have to do some compensation for these things. I won't go into the details. There are various thoughts about it. But of course, since everything is open, now you can have a meta reviewer that says, hey, the review you wrote, I agree with that, but this is not it. Or that's a good idea, we can go in. And then, of course, we know recursion, we're computing people, can have a meta-meta reviewer writing a meta-meta review and so on. And then the author is part of the discussion, may comment on the review or the meta review and so on. Essentially, you have an open scientific discourse. The way it was done in the earlier times when, Einstein and Heisenberg were exchanging letters, and the scientific community was reading these letters, of course, with months afterwards, doesn't matter. It is not, I wrote a paper, you are reviewing it. We're not reviewers anymore. There's no one final version. The reviewers are commenters. We are in a scientific discussion, and the end result of this discussion is what is the end result. And of course, the paper may be changing, may have multiple versions. It was initiated by an author or a set of authors, but it's a scientific community that cares about this, that advances. It is a whole different way of progressing and of interacting and of discussion, because we opened up the reviewers. Again, even that part is being tested in various parts of ACM and also outside ACM. KDD has one version. As I said, I'm presenting everything at the extreme. Some not at the extreme level, but reviews are open in KDD, in parts of Chi, Graph, and so on. And I think we should all take careful steps and move in that direction, making sure that we protect the young, we protect the weak. But openness is key. Another aspect that open science calls for, again, I'm presenting it at the extreme. Open research pre-registration. Let's look at this. This calls for full disclosure. What does this mean? So we are in the part of where we decide what is our hypothesis, what is our method, what results intermediate will come in. So let's look at the current research process. The researcher has a hypothesis, decides a method, data, software, hardware, and so on, and then comes up with some results. They don't like the results, they throw them in a garbage can, they go back, they evaluate the hypothesis or the data or their method, and at some point, eventually, they're happy, they write a paper about it, they send it to the world, that's it. And the researcher knows everything that they did, the hypothesis and the steps they went through this. The world, all they see is the final paper. None of the rest is known. This is harking. This leads to harking. Harking stands for hypothesis after results are known. And it is like this guy, okay, shot in the dark, and then wherever the bullet hit, then they say, this is what I meant. This is what I wanted to achieve, okay? Harking, it's a great term. So in open science research dissemination, with pre-registration, it says, no, this should not be the picture. The entire process, the world, go back, okay, now, the entire world should know everything that the researcher did, including the back and forth. And there are organizations like the Center for Open Science where you can go and say, I have this idea, this is my hypothesis, this is how I'll try to prove it. And you pre-register this. And you may say, but then someone else will look at it, and then they will be stronger. They will go after your idea. Yes, there is this danger. Again, there are ways to, I'm presenting it in the extreme, there are ways to have some protection for this. But the benefits are great, because as part of what you did, as part of pre-registering, you'll know all your failures. And the research community will not go and do the same things, will not go through the same path that otherwise it's hidden. If your final result is the 10th attempt, the 9 previous ones failed for one reason or another. The world doesn't know this. They go again and do the same 9 things and fail again and again and again. By pre-registering, first of all, you don't have any harking. By the way, harking is not necessarily bad, because you may be searching one thing you may be searching for silver and you can find gold. This is good. But often it's not that you found gold. You find something else and you say, okay, but that's what I meant. And then you are glorified. Okay, that's the. How do we evaluate research? Again, as I said, everything that we do, if you think about it, it is self-centered. We do it, for the most part, and the way we have metrics and so on, for the evaluation of the researcher and the glorification of the researcher. But in order to be open, you have to spend time to make things open. Your data sets, your methods, your software, and so on. This takes time. How can we ask of a young assistant professor or a young researcher to spend time to make things open where, because of the paper diarrhea, you remember the technical term, she is expected to write 15 papers in 1 year, and now with openness, she will only write 8. Okay, how do we do this? We have to change the way we evaluate research and therefore researchers. We have to talk about excellence, we won't lose that, and openness. There are many communities primarily the AI community has shown this way, is the delta and epsilon. When I was growing up as a scientist, a delta publication or epsilon publication or MPU, the minimum publishable unit, was not looked, it was scorned. I mean, it was not the good way of doing it. Now, as I said, you sneeze, write about it. You sneeze, another write about it. 20,000 publications submitted. That's fine, hooray, but let's just expose this. Register the tiniest of results you want about it. It's like a blog post, as I said. But when it comes to write a paper that should be evaluated and you should be judged about it, let it be on the difficult problems. Let it be on the comprehensive work that you did. And then you be evaluated not on the 177 little things that you wrote, but on the 2 in order to get a PhD, on the 5 or 10 that you wrote to get tenure, and so on. The National Science Foundation in the US is doing this when they're evaluating individuals that try, and in some other parts of the world. But it is sporadic. It's not the philosophy that we have. We have learned to evaluate ourselves and to evaluate our institutions and to evaluate research by counting. Now, I have 732 publications, 200,000 citations. Numbers, numbers, numbers we count. Well, we have to stop counting and go back to reading. And reading doesn't scale. We can expose things. Remember my map of all the paths? We can expose things. But when it comes to publishing, let's publish the hard things. Let's go after the hard problems and not the deltas and the epsilons. And there are many efforts around the world. COARA is the European effort I'm familiar with. More than 500 institutions are coming together and seeing how are we going to be evaluating research. Having excellence, but also having openness in the concept, in the direction of reading versus counting. And this is happening. CRA has an initiative I mentioned that ACM is participating with IEEE and so on to come up with some foundations. The other part is that in order to do all this, to do openness, you need some infrastructures, especially data infrastructures. Openness means also using open infrastructure, not just using your laptop for all your experiments, which in a year or two you'll replace it and then you'll lose everything. Openness requires some quality and some permanency. And I'll just mention open air, which is Europe has been a pioneer in terms of openness and open science. And open air, and as of now, what is called the European Open Science Cloud, EOSC, are the big infrastructure that are being built in order to support open science processes and open science research in Europe, but also around the world. This is a fancy picture. I had to have one in my presentation to show you the complexity. And we're developing an open air, has been developed, research graph that contains all kinds of entities in the direction of what a knowledge graph-based publication would be, and then lots of data sources, lots of analytics, and lots of value-added services on top of it. How many of you are familiar with OpenAlex? Okay, which came up from the Microsoft Academic Graph. OpenAlex is great. It pales compared to what OpenAir is offering. Check it out. You don't have to be European to check it out. But it's all sciences, 200 million publications currently, hundreds of thousands of data sets, and so on. It's trying to come up with the knowledge graph of all scientific output at the metadata level, okay? Doesn't replicate the actual data sets. Publications are where they are supposed to be, but then it brings them all together and it connects. And that's a resource that many large language models are trying to. Lots of data sources. And there is an international outreach. OpenAir is European, but it's connected to many other efforts around the world, including ANS in Australia, Nectar, RDS. The locals must know some of them, some of these infrastructures. And let me come to the last thing, open access. Openness was everything open, but remember that open access is that you don't pay to read, like you've been doing until now, but you pay to publish. And ACM has been pioneering again of how to approach open access. Most of you, I assume, you get access to the ACM Digital Library and other digital libraries like this because your institution is a subscriber. Or in certain cases, because your country has a country-wide license for this. Well, the ACM Council 5 years ago decided to adopted the goal of opening the digital library within 5 years. This was right in the middle of the pandemic, by the way. Given that it can be sustainable for ACM, because it costs to publish, it may take longer because of COVID. That was a decision at the time. And then some motherhood for the end. That was 5 years ago. And to round it up, it became January 1st, 2026. We have not been sustainable yet. We're working in that direction. But the ACM Council, besides the 2020 decision, in a repeated way last year and a couple of months ago, repeated the decision that we will invest some of our resources in order to be open, because this is the right way. This is the philosophy that we're doing it. All publications and related research artifacts, data sets, and software that you are uploading together with your papers will be openly available to everyone starting January 1st, 2026. We are the first society that is doing this. We are the first publisher, commercial or not, that is doing this. And we are doing it also in a way that respects the author. If this is a picture, you know, this is the digital library, the author, journal conference, whatever, the paper is there, and then the reader. In the old system, we have the paywall here. And in order to read, you can read individually, you can have access individually, but usually it is your institution or your country that is paying the dollars for you. In the pay to publish, you're still, the focus of ACM is the author should not pay. Ideally, the institution should pay, or the country should pay, in a symmetric way of what we used to be. And that's why we have the concept of ACM Open, which, according to how much you publish, so the MITs and the Tsinghuas of the world and the Oxfords of the world will pay a lot more. And those who publish very little, we won't pay anything. And then, of course, it could be that if you don't belong to an institution or a country that covers this, individually, for every paper, you'll pay article processing charges. Hopefully, this will be minimized. And I want to emphasize, all societies, all publishers, all they have is APC. They don't have the concept of let's pay at a higher aggregate level. And all the others are looking at how ACM will do. So it's very important for the community to support this. We're doing it, of course, we're subsidizing people from underprivileged parts of the world. And we're also in the transition period that we are entering January 1st. We're reducing, again, we're investing part of our reserves in order to make this work. So that if you belong, so the web conference next year in Dubai, in order to publish, you have to pay for your paper. Hopefully your institution or your country will have paid. If not, a small percentage, maybe your SIG can pay, but ACM has reduced by a lot in this transition period. The author is the center. And we need about 2,500 institutions to join ACM Open so that we are sustainable. We are at 1,800 and change. And if I look at Australia, these are all the universities that have joined ACM Open. Thank you for those of you that are Australian. I'm not showing the rest of the world. We are in Australia, so wherever I'm giving this picture, I'm pointing. So you see CSIRO having joined. This is very key, you know, a funding agency and research central to Australia. We see a few, all the key universities in Melbourne, University of Queensland, University of Sydney, University of Technology, Sydney. Where you belong? Yeah, okay. But not everyone is here, okay? There are universities, some major universities that are not part of ACM Open. So if you are among those in Australia or anywhere else, talk to your department chairs, talk to your deans, talk to your libraries to join. This makes a big difference. Let me conclude. Open science opens what we do to the world. It opens it to our peers. It opens our data sets. It opens our processes. It is a healthy interaction, eventually to society. It increases collaboration. It increases reproducibility, which, for me, it should be a criterion for acceptance of a paper, not an afterthought. You accept a paper, and a year later, we see if it is reproducible or not. SIGMOD and many other SIGs, many other conferences have reproducibility processes. But as you saw, more than half of our papers are not reproducible. Are they correct? How do we know if we cannot reproduce it? So open science opens up, and many great benefits are there. It's easier said than done, but we are moving in this direction, not just ACM, not just the web conference, not just ACM, not just computing. All of sciences are moving in this direction. And in order to do open science, we need our technologies. Without computing technologies used in a very heavy level, open science is not implementable. So let's move in this direction in order for us to trust each other and for society to trust us. And just for the benefit of those of you who are not in the opening ceremony, I'll show this picture again that, for me, captures the concept of trust in the most vivid way, in the strongest possible way. You see, how these people trust each other. And if you look at the most trustful guy, the guy at the bottom, his body is shaped like an A. And the way the lady curves her body in the middle, it's like a C. And then if you let your imagination a little bit more for the top guy, okay, let's assume that it's M. So trust means ACM. I am ACM. You be too. Thank you.
Any questions?
Yannis, thank you very much. In our role as the steering committee for this conference, we've looked at many of the topics that you've discussed. If I look at the reality why 1,000 people, 1,500 registrants for this conference come, the presentation part is actually not so important for them, as is evidence that many presentations are not of particularly high quality. The presence portion is also not very important for them, but what's very important is that they get their work published at an A-level conference. And the interaction and the reason for coming to the conference is a requirement to have their paper accepted rather than a motivation for really coming here. That's a process because of the way they're evaluated in their home countries. It's a funding process. To change that requires a fairly major mindset. And I think that the major impediment to that entire process is scalability. In a world where you have Einstein and Heisenberg and Nahor talking to each other, the community is very small and people have time to evaluate other people's works. If you look at the publication cycle of our colleagues in social scientists, a full journal publication can take up to 6 or 7 years to be published and validated. ACM has grown its conference series because timeliness is very important. But whether you do it in the short term or the long term, when you have 5, 10, 15,000 submissions and 10, 20, 30 conferences where people can go, the numbers are so large that it's very difficult for me to believe that the open process, where people need to have time to evaluate, to document, to do cyclical reviews of presentations, our problem, very realistically, is to get reviewers to write more than 2 paragraphs in a review, which is something that doesn't happen in any other scientific discipline that I'm aware of, and that all has to do with scalability. So do you think that this process can really scale? Apart from the problems of public-private partnerships, where there are patent issues, where there are economic constraints, where there are all sorts of other things, do you think that scalability and the scale at which our research takes place, that's an impediment that we can overcome?
You touched upon a whole bunch of issues, so I will try to address some of them. Let me say the easy thing, how we are evaluated is different in different parts of the world. And whatever change we make at the global level, we have to be cognizant of these differences and respectful of people's careers and progress and so on. On the element of the thousands of publications and submissions and reviewers, what open science says, and what I'm saying also, is that this is a broken system. We cannot continue like this. This is, again, sneezing, writing about it, sneezing, writing about it. And a week afterwards or 5 weeks afterwards, nobody will remember the fact that you sneezed. And the scale, the way it goes this way because we are evaluated by numbers. And then we are in the rat race. Let's publish more, let's publish more, let's publish more. It's a mindset change that will not happen tomorrow, but we have to change our mindset, stop being in this rat race. Because the more we publish, our ability to read doesn't change. Oh, AI will read this. I could read this and could come up with summaries and so on and so forth. But even in these summaries, I don't think that most of what we write now will matter. So if we go back to a much smaller scale, emphasize the more difficult problems, write less, expose, I don't care. But when it comes to publishing and peer review and validation, the scale has to become much more reasonable, even as the community is growing. And when we have this different mindset, many of these things are applicable. And it is not true that other sciences don't have this scale problem. But they do it, the publications are at the journal level. And they have no problem traveling to conferences because they have their own conferences. Okay, they don't have thousands of conferences, but still they have many conferences. And their presentations are more in the sense of interaction, our own posters, our own plenary things, and so on. And I think computing, after we fix our journal process evaluation, which is an issue of speed, and we can do that, okay? Because it's not at the scale that we have now in conferences, but will be at a much lower scale. But we have to pay attention to this. This is a weakness of our community. After we do this, then I think we'll have fewer conferences, but much more interactive. And people will be coming in to discuss, to present their work, not necessarily their paper. Their paper will be in a journal, like other sciences. Lots of moving parts, lots of things have to be done until anything is done. But science, even the other sciences are moving in this direction, and I think we cannot afford to not move in this direction.
Okay, and which is the precondition? Is it the evaluation, the career evaluation process, or is it the open science process that will lead to a new career evaluation process?
I don't think there is a clear chicken and a clear egg. I think these things have to be organically cross-fertilized and mature together in order to go to a different world than the one we live now.
Thank you, Yannis. It's a wonderful talk. And I also believe that being open, being transparent is one of the ways to build trust, and it is a good direction. However, you have not perhaps elaborate on the challenges. And one of the challenges that I see is the assumption that all the actors in the system are good, so.
No, I showed the faces, you know.
I know, but you know, we in the organizing conferences, right? We deal with reviewer collusion, double submission, plagiarism, using LM to write papers even. So, in your position as the ACM president, and could you elaborate some of the things that perhaps ACM is thinking about to build this trust, to build this excellence, and have even more greater integrity? Thank you.
What you are touching upon is very important. In principle, it's orthogonal to openness. I do have 2 or 3 slides for this on my closing ceremony intervention and presentation. But just to say quickly, as I kind of touched upon when I talked about open reviewing, many of the difficulties that exist, many of the bad players will not be able to act badly when things are open, because they will be exposed. On the other hand, some other doors are opening for even worse behaviors when you're open. I didn't go into any details of this. I just wanted to give you an overview of every aspect, every dimension of open science. But these are not unique to ACM or to computing. All the difficulties with openness and the rotten apples in the fruit basket, other sciences are facing. And there are ways to deal with it. Not because I'm a data guy, but the more data we collect, the more we'll be able to detect unethical behavior. And ACM, together with sister societies, I mean, as I said, I'll say a few things in my closing talk, are working in a direction that we really educate our community and also put pressure on the bad actors to become better. What you are mentioning is we're trying to create a beautiful world, and we have some, let me not use a very heavy word, some parasitical behaviors that really destroy all this effort, and we have to do something about it.
Oh, I have a historical problem here. Since the generation of Michael Faraday, a scientist is whoever scientists listen to. And no one scientists think is a fool is a scientist. But now we're sacrificing that because to be part of this discourse community, you have to have a university position or happen to have been born in the right country. In the ancient world, to be a scientist, you needed to be a prince or a priest. Now you have to be a professor. I've never had a university position. I've got 60, 70 ACM papers. That's been very, very difficult and costly over the years. But for someone working in small business, that $60,000, $70,000 you've just added, that's going to be hard to make one's boss or one's stockholders agree to. So we're pushing out everyone who isn't a professor.
Let me respond. And if I do not answer your question, please let me know. let me go in the other direction. First of all, let me talk about the reader. We are opening up the scientific results to society. The concept of citizen scientist, which didn't exist before, and if you have to be a subscriber of the ACM Digital Library, obviously no citizen science would do that. Now things are open. And citizen science, not necessarily so much in computing, but you read the news, oh, this 6-year-old boy had a telescope and the mother did this and so on, and they discovered a new star. So there are examples like this that by opening up the scientific results, by opening up our publications, our data sets, whatever, we're opening it up to interested parts of society to be able to be part of this discourse, to be able to read and then discover, not only without being a professor, but without being a scientist at all. So there's a great benefit. Of course, now you're saying, okay, many readers were paying, not everyone, but whoever was paying, but I could author something without having to pay anything. But now I have to pay. I guess this is your complaint. First of all, you don't have to be a professor. You can be in other institutions that are not universities, still do research. But now as an individual from a company, I understand that this is the context in which you're posing the, you have to be paying. It is, I don't think we have addressed this specific case that you are mentioning. And certainly, thank you for bringing it up. I'll go back. But in the overall approach, if you saw, I had ACM Open, which is at the institutional or the country level. I had per article paying, but also had the third case that says ACM subsidy for cases under privileged contexts that people cannot afford to pay, and yet they have something to write about. Maybe you're falling in this, maybe what you are describing is one category of cases where we could take into account. Usually it's geographic, but also individuals. We have cases where people are retired, they don't belong to a university anymore, and yet they still publish. We do address cases like this. Someone from a private company, I don't think we've addressed it as underprivileged or a special case, but we can look into that. There are conferences that are organized by a special interest group. This one is SIG-Web that is organizing this. The SIG itself, from its reserves, goes and pays whoever does not belong to an institution that covers them when they publish. There are cases that the SIG does not do it, but as I say, ACM does it. So there are many avenues beyond belonging in an institution that someone can publish and have their cost, the cost of the publication covered. Personally, and that's far from, it's not easy to do it. I hope that ACM transforms itself and has other resources that has, I should say, funding from other sources, I should say, that you should never pay to read or to publish, and that the whole publication cost will be covered from other funding paths. But we're not there yet in any way. But thank you. As I showed in one of my slides, the author is the main motivation for whatever we do. And there are special cases, and we'll do our best to cover that.
Thank you for the talk. One of your big motivations for open access was increasing public trust in science. And you gave examples of, I guess, kind of like divisive issues like, I guess, climate change. And I mean, yeah, there's like a lot of topics in these areas. And certainly, as a scientist myself, it's very compelling to say, oh, if we just make the data open, that will convince people. But I also realize that everyone forms opinions in different ways and beliefs. And so I'm actually not as convinced that, or like it's not clear to me that there's a link between making all of the research open and changing public opinion. And so I was wondering what evidence you have to support that hypothesis, user studies, experiments, something like that.
First of all, I agree with you that just by making everything open doesn't achieve trust, doesn't achieve reproducibility. It's just one part of it. It's one step that together with other steps can lead us to where we want. But it's just increasing elements. The fact, I gave you an example with vaccine discovery. The fact that everything became open really accelerated the whole process, and we reached to have a vaccine. And society, well, not in its entirety, unfortunately, believed in the results of the scientists, and of course went and got vaccinated. The reproducibility, before I go to there, one of the key things that all scientists we have as problem, and I would say computing scientists even more so, is how to take our science and make it publicly palatable, publicly understandable. So besides being open, we also have to get our act together and articulate our science in a way that the public can understand. Reinforcement learning. Okay, the public, we got the Turing Award winners of this year, reinforcement learning. Does the public understand the significance of this and what reinforcement learning means? I mean, maybe they'll say, you know, I'm taking you, I'm beating you, you know, I'm reinforcing that you learn. There is this other aspect that is beyond openness that we have to work on. Now, evidence that by opening things, the public has more trust. Other than what I said in COVID, and the fact that more citizen scientists, at least in Europe that I know, many more citizen, the number of citizen scientists that they identify this way has increased. The more the data results are opening. Does this mean that society trusts us more? Possibly yes, possibly no. But there's definitely some evidence, maybe not hard evidence, that things are improving in this way, where more people are exposed to the science that we understand. But besides, beyond openness, a lot more needs to happen in order to really achieve that. But without openness, we won't. So it's a necessary condition, but it's not sufficient.
So I think it's over here, Yannis. First of all, thanks for a very clear presentation of the whole open publication approach. It's kind of the nicest and most clear presentation of what's behind this and what's being motivated by it. So that was very, very much appreciated.
Thank you.
I think that you've also raised a vision of that's attempting to address problems that have been in our ecosystem for 30 plus years, at least for as long as I've been involved in it. But I'm not sure that this is necessarily going to be the full solution without some more thought. And the specific thing that comes to mind, and I'm going to use my country, Canada, as an example. So Canada right now, I noticed in your graph was pink, so I went and looked it up to find out why we're pink and not red. And I'm at a university which is one of the bigger universities in the country. I'll say it's in the top 10 in the country. And we currently have dropped our subscriptions, institutional subscriptions to ACM and other organizations over the last couple of years because of the cost factor, okay? So I'm pleased to see that this is gonna open it up. So right now, in order for me to address that problem, I pay $138 or something and I get access to the ACM digital library every year. So you're gonna save me $138. Given that it's reducing the amount of funding that's going to the publications and basically passing those costs onto the research grants of the individual researchers in the universities, for all intents and purposes. My question becomes, how are you going to motivate Canada and Canadian universities to sign up for this open prepayment plan? And I'm going to use Canada as an example because when I looked at it, there are currently 4 institutions that have signed up for the open prepayment plan, hence why it's pink. One of them is a relatively smaller university in the country, and it's got a lot of students, but it doesn't have a big research profile like the University of Toronto or University of British Columbia. And the other 3 are all federal institutions, okay, that are specifically signed up so that their staff can effectively have their publications paid for. But they are only government research organizations. They are not scientific research organizations in the way we think of institutions. So I know this is a long-winded question, but I don't think the ACM's treasure trove is going to be sufficient to be able to cover off the prepayment of these open publication fees going forward when the typical fee is over $1,000 a paper. And, you know, kind of if you do that math, I'd rather pay $138 and get access to it myself than pay what, as this gentleman pointed out, could be, I've got a big group, 12 PhD students, each of them produce 2 papers a year. You could be looking at an awful big bill here on, quite bluntly, a fairly small grant. So I'm just wondering how you're going to handle this transition.
Canada is an outlier. First of all, it's an outlier in a good way. The way our Canadian colleagues have described it, we are unreasonably successful and advanced in science compared to our finances, which is not true for many other parts of the world. And we are very close to closing a deal with Canada because Canada also, I mean, the US, it's often individual institutions that handle with that. Of course, there are other parts of the world that are the country level, and it's not talking about, Greece is one example, but Greece is a small country. India has a deal at the country level. 6,000 public institutions, it is ONOS, one nation, one subscription. So India joined ACM Open, 6,000 public institutions are now covered. Canada is also working in consortia, and not, I mean, very few individual institutions, as you said, have joined. But we're very close to closing a deal with Canada from what the publications department of ACM is telling me. And so this problem will be solved. To the extent that such problems are not solved, because you never know what will happen, it is, as I said, ACM is pioneering this approach. And we did it by listening to what the community, the overall community has been asking for. And as we see problems that are not solved by our model, we'll be changing it, we'll be calibrating it, we'll be evolving it in order to serve our authors and our scientists. The main motivation is not to make money. We need to be sustainable one way or another. But the main motivation is to make sure that the scientists, the authors that want the stamp of quality that ACM cares about, that they want to be present in conferences like the web conference or in journals, you know, that are valued by the community, will find a way for them to keep publishing. But it's a work in progress. Let me say it's an experiment that is very well motivated, and its purpose is good, but it has difficulties because it's new. I don't remember what the optimistic with Canadian institutions are the only ones where I also felt compelled to go and talk to the head librarian of the University of Toronto and some others, because Canada is so important and yet so far from joining ACM Open. I also spoke to a few other countries at this level, but Canada was very special. But I think we're close to having a deal.
Okay, let's.
Hi, I have one quick question. Hi, Professor. Over here. Yeah, my name is Kevin from Swinburne, Australia. My question is, from last year, the web conference used an open review system. Yeah, the system is very great, but one of the requirements is ask one of the author as a reviewer. So I don't think this kind of fair, because I'm an author and I review other papers. Maybe I have some, the things. So I think the web conference maybe invite some expert review to review our papers next year, because one of my colleagues, his paper is rejected, and one of the review, he even doesn't know the background of the paper and give a low score. And during the rebuttal period, maybe before the due date, he just responds, okay, thanks a lot for your response, and I will keep my score, thanks. So I think it's unfair, and I don't think it's a great requirement for this. Thank you.
Can you repeat what is the requirement you're referring to? I missed it when you talked about
we need to select one of the author as a reviewer.
One of the authors of
Yeah,
some other paper to be a reviewer?
Yeah.
I see, okay. Well, this has nothing to do with openness. Openness is orthogonal to this. And I assume that last year this happened because there are many papers and you need to find reviewers. And if you are increasing the load of reviewing by writing a paper, well, you should also go back and offer to the community some of your reviewer time. Now, many people, I know many conferences are trying to do this. I came from the Computer-Human Interaction Conference earlier this week in Yokohama, and this is something that they are applying as well. Many people behave ethically, and they write correct reviewers, although they're authors. But as Erwin said, some people will be unethical. And this can happen whether you are an author or not of another paper. An independent reviewer selected can still do exactly the same thing that you said. Of course, in the situation you are describing, you may have the case, oh, the worse the reviews I wrote for other papers, the higher the chances that my paper will be accepted. And yes, there will be some people that will do this, but asking for authors of submitted papers to review some other papers, it's a way to handle the scale. We have reviewer fatigue. We have the scale is at the thousands, and we need at least 3 times. For this conference, I think from the opening, every paper was reviewed by at least 3 people, and some of them were reviewed by 8 people. This is insane. This is not science. This is almost crapshoot. We have to do something about it and focus on the good science, on the difficult problems, not the sneezes. So that effort is partly, it may happen that a particular reviewer was unfair, but as a system is an effort to reduce the scale.
Okay, let's thank Yannis again for his thought about
you.
open science.